Have you ever imagined a volcano erupting without any warning? No rumbling, no earthquakes, no swelling ground, just a sudden burst of lava, ash, and gas? That's exactly what happened with Mount Veniaminof in Alaska. In 2018, it erupted so quietly that even experts at the Alaska Volcano Observatory didn't notice until it had already started. This phenomenon has a name: stealth eruptions, and today, we're diving into what makes these eruptions so deceptive and why understanding them is crucial for both science and safety. Mount Veniaminof is one of Alaska's most active volcanoes. Rising above the snowy landscapes of the Alaska Peninsula, it's part of the Pacific Ring of Fire, a hotbed for volcanic activity. But Veniaminof behaves differently from most volcanoes. Since 1993, it has erupted 13 times. Surprisingly, only 2 of those eruptions showed the usual warning signs that scientists rely on, such as ground deformation, swarms of small earthquakes, or changes in gas emissions. The rest, practically silent. So how is this possible? The answer lies deep beneath the surface, in the very structure and behavior of the volcano's magma chamber. Scientists have found that Veniaminof's magma chamber is relatively small, located deep underground, and experiences very slow magma flow. Unlike more explosive volcanoes, where rapidly rising magma causes pressure to build and forces the ground to bulge or crack, the magma here seeps in gradually. It doesn't push hard enough or fast enough to deform the Earth's surface significantly. That means GPS sensors and satellite imaging often pick up no sign of activity until it's too late. But there's more to it. The rock surrounding Veniaminof's magma chamber is unusually warm. This might seem like a small detail, but it has huge implications. A normally colder, more brittle rock resists pressure and cracks, is elite, creating earthquakes or surface movements that warn scientists of rising magma. Warm rock, on the other hand, is more pliable. It absorbs stress instead of fracturing. As a result, the magma can quietly move into the chamber without triggering seismic activity or surface swelling. To understand this better, researchers use sophisticated computer models to simulate what's happening inside volcanoes like Veniaminof. They tested different scenarios, changing the size, shape, and depth of the magma chamber and the speed of magma flow. What they discovered was fascinating. Stealth eruptions are most likely when 3 factors are present together: a small chamber, slow magma input, and warm ductile surrounding rock. When all 3 align, the volcano can build up enough pressure to erupt without any traditional warning signs. These types of eruptions are not just scientific curiosities, they're potential hazards. Sudden eruptions can be extremely dangerous for nearby communities, as well as for air traffic. Ash clouds from volcanic eruptions can reach cruising altitudes of commercial planes within minutes. For places like Alaska, where many flights pass over active volcanoes daily, stealth eruptions pose a real risk. In fact, the eruption of Mount Veniaminof in 2018 led to ash plumes rising high into the atmosphere, prompting aviation alerts that came after the eruption had already begun. So what can be done? Traditional monitoring systems like GPS and seismometers can't detect these eruptions in advance. How can we stay safe? Scientists are now working on more sensitive and diverse monitoring tools. These include borehole tilt meters that can detect tiny changes in underground pressure, strain meters that pick up minute shifts in rock movement, and infrasound sensors that can hear low-frequency sounds from inside the Earth. There's also a growing use of gas sensors that can spot subtle chemical changes, and machine learning models trained to recognize unusual patterns in background, seismic noise clues that humans might overlook. In short, the key to detecting stealth eruptions lies in looking deeper and listening more carefully. While these events are still rare and hard to predict, our understanding of them is improving rapidly. Mount Veniaminof has become a kind of natural laboratory, helping scientists uncover the hidden processes of our planet. It's a reminder that the Earth is full of surprises, some loud and violent, others quiet and stealthy, but all worth paying attention to. As we continue to improve our tools and deepen our knowledge, we may soon be able to spot even the most silent threats before they erupt. Because when it comes to volcanoes, silence doesn't mean safety.